So at this point, we're going to fill our dissolved oxygen bottles. It's important to do all three of these at the same time. You want to rinse first. You want to rinse from the side of the bucket that you've collected the seawater in. You just need a little bit of water. Put the cap back on. Shake it to rinse. And then discard out of the bucket. You will do this 3 times with each bottle. This makes sure there's nothing left over from the previous sample, nothing that can contaminate this sample. Once you've rinsed it 3 times, you're going to fill it from your sample bucket. You need to make sure that the cap is on tightly before you collect your sample. The jar is completely submerged. You then remove the cap, let all of the air bubbles escape the jar, as you can hear. Make sure the cap is turned upside down so bubbles can get out of that as well. So you're filling your jar completely immersed in the bucket. You want to cap it while it's in the bucket. So it comes out capped and full of water. You want to check this to make sure there's no air bubbles in it, which there shouldn't be if you filled it completely and capped it while it was underwater. You'll do that for each jar all at the same time. We're going to rinse this one again 3 times. And when you're rinsing, you're always rinsing from the side of the bucket, from the holes in the side of the bucket. You're not adding anything that might contaminate your sample. It's important to do this very quickly after you collected your sample. You don't want any of the oxygen concentration in the water in the bucket to change. You want this to represent the conditions at your site.
So at this point, it's been about 5 minutes, and we're going to look at our water temperature and our pH reading. And the meter here has 2 numbers. The top number is the pH and the bottom is the water temperature. And it looks like the water temperature is 6.0 degrees Celsius and the pH is 8.11. So I'm going to record that.
Checking for bubbles. And one more time with that last bottle. And again, it's cap on, jar in the bucket, underwater, fill it, recap it while it's underwater in the bucket, and check for bubbles. So at this point, the jars are ready to be fixed. We're going to add 2 chemicals right now to all 3 jars at the same time. You don't want to do one and continue. You want to add both reagents all at the same time. The reagent bottles are marked nicely, 1, 2, and 3. So you start with number 1, of course, the manganese sulfate. You add 8 drops. And again, we're doing this to all 3 jars of sample water. We try to be consistent. We rinse everything 3 times, and we always add 8 drops. That was the first chemical. The second one is an alkaline potassium iodide solution, conveniently marked number 2, the second one you add. And again, it's 8 drops. And we do this to all 3 jars. you'll notice a flocculate beginning to build up in here. After you add the first 2 chemicals, you cap each. And shake. And you'll notice a very heavy flocculate. That's all of the oxygen molecules bound together with these 2 reagents we just added. This sample is now fixed, for lack of a better term. It cannot change the concentration of the oxygen at this point. You could take these samples away from your site, take them home, as long as they're done within the next 6 hours, as long as the titration is complete within the next 6 hours. These samples are all set. What we have to do now, we will shake all 3 of these. It gets very cloudy. We have to wait until this cloudy layer settles out, and you'll notice that it will settle out. You'll have clear water at the top and this flock layer at the bottom. Once that flock layer drops below the shoulder, you can shake it again, but you need to wait until that happens. So I'll shake these last 2 jars. And it needs to be a pretty vigorous shake. You're not going to damage anything. And depending on the temperature, colder water means that these will settle out much slower. Warmer water means that they'll settle out much quicker. So as you get later into the summer, this will be a quicker step. But for now, we have to step back and let these settle at least below the shoulder. And then we can shake it again, let it settle a second time, and then add our 3rd chemical. So while you're letting these settle, and you can set these back into your kit and allow them to settle.
Now those things, since they've had the oxygen bound up, they're good for up to 8 hours before you do the next process, which is called the titration. In this state, they're quite stable. It's when you add the next chemical, which is the sulfuric acid, that eats up the precipitate. They're typically good for about 45 minutes. So in this state, it's good for about 8 hours. You can go on and do your other tests, and then at your leisure, you can do this back at home. Do it in your sink, kitchen sink, in an area where things are stable. It's not as windy, not as cold. Much better place to do it.